Today's notes are on solving multivariable systems of equations. Now, basically what this means is in your algebra and algebra 2 days, you learn how to solve systems of equations with x and y. On these kind of problems, you're going to have many variables, maybe x, y, and z, maybe even more than that. So you might have 4 variables or 5, or even we're going to solve systems with perhaps 9 different variables in them. Now, if you're good at solving systems with 2 variables, you can handle solving systems with any number of variables. There's a few rules that you can follow. So we're going to line up all the equations, and we may interchange those rows or those equations. Second rule, you can multiply a row or an equation by any number besides 0. And third rule, you may add a multiple of one equation to another. So let's take a look at an example of this. All right, jot this down, please. First example says we want to solve this system of equations. Notice we have 3 variables, x, y, and z. Also notice I've lined up all the variables. So if things aren't lined up, that's your first step. Line things up so your x's are first, then your y's, then your z's, then your equal sign, and then your answers. Okay, so what we want to do is combine 2 of these equations to get any of those variables to be eliminated, to cancel out. And it doesn't matter. We can choose to try to eliminate the x's, the y's, or the z's. It does not matter. I'm going to choose to multiply to eliminate the z's. So to do that, notice these 2 equations here, these last 2, one of them is 2z, one has just 1z. So I'm going to choose to multiply this middle equation by -2. When I add that to the bottom equation, the z's will be eliminated. So okay, so the middle equation becomes -2x, excuse me, plus 4y minus 2z equals 8. And the bottom equation, if I bring it over, is 3x plus 4y plus 2z equals 3. So now if we add these 2 together, we can see that the z's will be eliminated, and we'll have just an equation with x and y. So I have 1x plus 8y equals 11. Perfect. So now we need to add 2 different equations together to also try to get those z's to be eliminated. Okay, so in this case, I'm going to try to add the first and second equations. So if I add the first and second, the z's won't be eliminated, but I want to try to multiply that second equation, in this case, by -3. And if we add that to the first equation, the z's will be eliminated. So I'm going to bring down the first equation, which is 2x plus y plus 3z equals -8. And if we multiply the second equation by -3 and bring it down, we get -3x plus 6y minus 3z equals 12. Okay, what do we get if we add these together? We get -1x plus 7y. The z's are eliminated. Perfect, that's what we want to happen. Equals 4. Okay, so your first step in solving these is to combine 2 equations to get any variable to be eliminated, then combine 2 different equations to get the same variable eliminated. So now at this point, we have a system of equations with 2 variables, x and y. This is similar to what you've done in the past. So I'm going to just line these up. I'm going to bring this equation down, and I'm going to write it down here, x plus 8y equals 11. Now normally you'd multiply one equation by something to get the x's or the y's to be eliminated, but check this out. In this case, we already have a -x and a positive x. If we add these, the x's will be eliminated. So that gives me 15y equals 15. And solving for y, that leads to y equals 1. There's our first variable. Okay, once we get our first variable, we plug it into one of these equations to try to get our second variable. I'm going to choose this one right down here. This is going to be x plus 8 times 1 equals 11, which leads me to x equals 3. There's our second variable. Now that we found that, we need to plug all three into one of these equations, one of the original equations up on top. I'm just going to choose this top equation here. So I'm going to plug 2 times x, or 6, plus y, which is 1, plus 3z equals -8. Okay, I know this is going to give me 7 plus 3z equals -8. If we subtract 7 from both sides, we get 3z equals -15. And dividing by 3 gives us z equals -5. And there's our three variables. Now, if we want to check our work, we plug x, y, and z into every equation. There's only one set of points. There's one x, one y, one z that'll make all three equations true. And here they are, 3 for x, 1 for y, and -5 for z. I'm going to write my answer as a point or an ordered triple, and there's my solution. Now, there are some special cases you encounter with these. It is possible to get no solution. So for example, if you ever are eliminating some equations and you end up with something like 5 equals 3, it makes no sense, so there's no solution there. Let's say you're eliminating equations and you get 5 equals 5. Well, that always works. That means you have an infinite number of solutions, so that's infinite solutions. Now, a couple words you might see. Inconsistent is the word that we use for no solution. I prefer just saying no solution, but sometimes you'll see or hear the word inconsistent. Dependent is a word we use for infinite solutions, meaning any value of y is just dependent on what you plug in for x. Okay, so let's look at one more example. We want to solve this system of equations, and one thing kind of strange with this system is that notice you don't have any x's here and you don't have any z's here. Now that's okay. We can have systems like that. So don't let that bother you. Okay, so let's try to combine some equations to get some of the variables to be eliminated or to cancel out. All right, I'm going to start by adding the first and third equations together because I notice we have x on this first one, -x on the second one. The x's will be eliminated. So if we add the first and the third, we get 0x's plus 3y minus 3z equals 0. Now the nice thing about this particular problem is that the second equation already has the x's eliminated. That gives me y minus z equals 0. And now we have two equations, two variables, y and z, so now we can solve for y and z. Okay, let's try to get these z's to cancel out. I think if I multiply everything on the bottom equation by -3, it'll get those z's to cancel. So let's bring that down here. So first equation I'll just bring down to start. That's 3y minus 3z equals 0. Second equation, if we multiply everything by -3, we get -3y plus 3z equals 0. Okay, so if we add these together, well, wait a minute here. Adding the y's together, that's gone. Adding the z's together, that's gone. So on the left, everything's gone. Let's just write that as 0 equals 0. Well, that's very strange here because everything is eliminated. Now, thinking of those special cases, if everything's eliminated, think about this. 0 equals 0 always makes sense. It makes sense, so that means we have a number of different points that will make this true. So there's an infinite number of points that make this true. So I'm going to write infinite solutions. Now, another word you might see with that is this is a dependent system of equations. Meaning, let's say you graph these three things. This first one, if you graph that, that's going to be a plane. This is going to be a line. This is going to be a line. These three intersect in an infinite number of points. So they might intersect along one of those lines. And all those points on that line are solutions of this system. So there's an infinite number of solutions. Okay, so that's how we solve a multivariable system of equations. I would suggest you get some practice with those. Be careful. The biggest mistakes people make are little mistakes. So careful with positives, negatives. Be careful with your addition and multiplication.